I can certainly see that.
Okay, let's go. Right, so hi, I'm Nick. I'm here to talk about why I'm building a rover, and I'm building it from junk. Lots of the sort of stuff tech or maker hobbyists are likely to have kicking around. Some of you who've seen my previous presentations will know I'm a live action role player, and I usually make things related to this. So the photo you can see on screen is me 2 weekends ago pretending to be a Star Wars rebel, and I'm running around in the woods shooting at my friends and being silly. Now, at some point, a convergence of ideas has led me to wanting some kind of moving thing that's remotely operated and can be interacted with on a human scale. So not a small indoor desktop-sized robot like you get in a lot of sort of school projects, but something that can drive outdoors over rough ground, over a large area, and have people walk up to it and hopefully talk to the person at the controls for some kind of sort of teleoperation and telepresence. Now, I've wanted to do something like this ever since I saw Robot Wars in the 90s. And I even got as far as buying some wheelchair motors, big batteries and so on, but it never really followed through because it was expensive and time consuming and difficult at the time. Also, amongst my lot of friends, we've often joked we'll end up driving robots around the woods as our mobility declines as we get older. And if this project works well, I think it could actually be good as a role for one of my friends who's really struggling with mobility at the moment and spending a lot of time basically sat down. And also, it came to pass, I'm very likely to be running a Star Wars LARP next year. And there are lots of robots in Star Wars, and it would be really nice if there was an actual robot you could interact with, a droid, in the game. People like that sort of thing in games. It's very popular. So how do I start? Where am I going to begin with this? I figured making something like this would be really quite a lot of work. While I never got around to building that entry for Robot Wars, some people I later became friends with had. And around the time that was happening and their participation was coming to an end and the show was winding down, I chatted to them at length about it and even helped them with some repairs at some point. And yeah, it was a big job. What I'm doing doesn't have to be so physically robust. It's not going to get in a fight with anybody or anything, but it's still a big ask, quite a big thing. And real outdoor capable robots are quite expensive things. We're talking thousands of pounds for anything worth fiddling around with too much. And even something like a Turtlebot, which is an indoor robot driven by a Raspberry Pi 4, if you buy the complete thing, it's like 750 quid plus. However, the world is very different now to the mid-90s. And things that were once preserved as serious engineers with serious budgets are well within the reach of hobbyist fiddlers. So I think I can have a go. Also, there were numerous things at EMF camp that people have built and were driving around in a field and kind of do a similar job. Now, our last droid, which we had last weekend, which was an Imperial Pro droid, was made of cardboard and carried around by a person. And I'm hoping to do something a bit more serious than that. I had a good dig around in my cellar and came up with a bunch of stuff. So I've got loads of microcontrollers. I've got old ultrasonic rangefinders, GPS modules, accelerometers, compasses, webcams, a Kinect, which was a really hot thing to fiddle with about a decade ago. And about the only thing I didn't have was a meaningful way of moving something quite big and heavy around. So I started looking into that. But before we go into physically building it, I'll talk a little bit about the two flavors of hobbyist robots. You pick your fighter. There's two sides to this, broadly two approaches. On the one hand, you've got RG Pilot or RG Rover. On the other hand, you've got Robot Operating System or ROS. And that is unless you're going to completely homebrew the software from scratch, which is frankly beyond most people's skills and the amount of time they've got to space on it. Time to spend on it. And RG Rover and RG Pilot are an evolution of the open source stuff you get on drones, for flying drones, making them easy to fly, making them predictable. And it's kind of come from the microcontroller size up. So as microcontrollers have got more powerful, sensors got more powerful, it's got better and bigger and greater. And it's very strong on being a directly controlled thing that can also follow a flight plan and do certain things based on sensors, and it's good on safety and all that sort of stuff. ROS, is from the academic end of things. So lots and lots of undergraduate and postgraduate projects on robotics have turned out large amounts of stuff for ROS. And it's usually running on a Linux computer, and initially it would have been very static on sort of robot arms and things, but as computers have got faster and smaller, it's tended to move into moving things and things like that. And there's lots of tie-ins to machine learning and AI cameras and all that sort of stuff. It's just a bigger thing. Now, for my project, I'm going to go with ROS because I ultimately want some things like face detection and route planning in complicated environments outdoors. And ROS is ultimately the more powerful platform, but that comes with challenges around the complexity, cost and power consumption of the onboard computer. And also this is a Raspberry Pi group, so I'd expect you to be a little disappointed if there wasn't one involved. A serious ROS project comes with serious expense, but Crufty the robot, that's what I'm calling it, is going to be built out of junk. So everything I'm using in the first day version is a scaled down slightly sort of thing from a big serious project, or old, which keeps this manageable in terms of budget and things, while I work out whether or not it's really going to work for me and what the final build will be. But nonetheless, right now, I've got something that weighs 15 kilos and has a kilowatt of motors involved. And if I fitted a seat on it, it could drive around with me on it. And going back to the motors, what I'm using is the almost ubiquitous hoverboard motors. I've used motors from secondhand spares or repair hoverboards for the first version of Crufty, and I'm very likely to stick with them because you can pick these up on eBay for about 25 to 40 quid each, and each of the two motors is rated for 250 watts. That's really cheap. That's loads of power for almost no money. And there's a reason of loads of maker projects starting to use these for comedy vehicles and little projects 6 or 7 years ago. So you just can't be that price. And the reason they end up getting sold as spares and repair is because when they're used infrequently, like if you've got one for your kids or whatever, the battery packs slowly discharge through the controllers very slowly, and eventually the batteries get flat enough that they refuse to turn on and recharge. At that point, to the average consumer, it looks dead. The motors, however, are very, very robust and almost never damage. Another factor in these getting used in lots of projects is there's a German hacker called Lucy who reverse engineered the controller boards back when these were big popular, and you can flash open source software and get brushless motor controllers for free, effectively, if you buy a dead hoverboard. It's very easy to spend over 100 quid on a brushless motor controller. Now, not all the hoverboards are compatible with this software. I'm running at about a 50% success rate on buying hoverboards because I've now bought more than 2, but the controllers are all right. And this gives you more than enough power for quite a chunky rover to move things around. The motors you get out of a hoverboard are hub motors, which means there's no gearbox, there's no chains, there's no drives. You just work out some kind of way of clamping the axles to whatever you move around in a suitable spot and apply power. And I've gone with, for now, just to learn about it, the simplest possible chassis, a rectangle of strong plywood, and I've put some 3D mounted printed mounts on for the motors. And you think, oh, they won't be very strong, but with some bolts in them, they're really strong. You can stand on it. Now, the open source firmware on the controllers is quite fiddly to flash, but once you've done it a couple of times, you get used to it. The controllers I've got, there's one per motor and they're linked up, and one per side, and there's a link between the two boards. And then each pair communicates over a sort of a serial protocol like you'd use for programming an Arduino or something like that between some other device and the motor controllers. This makes them quite easy to drive from something like a Pi or something like an Arduino. Again, this is another reason they're widely used in projects. And the controllers do a really good job of PID control, which is trying to match how much power they have to put onto the motor to a specific speed. So you can drive it really quite slow. It's not just dumb or firing power at the motor, and they feed back this current speed to the controlling device. They report on battery life and what the voltage is. And it's really, you get tons of stuff out of these controllers for very little money. The battery packs in them, however, are a little bit tricky. They're 36 volts or 42, absolutely fully charged. It's not high enough to be directly dangerous to a person, but it is very easy to kill other bits of electronics with it. A lot of power supply modules and things like that, they just won't take it. And you can start fires with it really easy because it will put out loads of current. And hoverboard batteries have a terrible reputation for starting fires. There was a whole rash of them. So if you start messing around with any of this stuff, don't leave it unattended charging. It's a charge it outdoors kind of thing because they can be a bit dodgy. But I've resurrected a couple of battery packs as well. So when you buy an old hoverboard, if you liven up the battery pack, you're getting masses of power and batteries again for pennies, almost nothing. It's almost free when the board when you liven it up with the board. So, and what am I driving it around with it? Another bit of junk out of the big cellar full of junk. A Wii nunchuck. Everybody had these for Arduino projects about 10 years ago. They were all over the place. You get a nice quality single-handed joystick, an accelerometer, and a couple of buttons you can read. And you just need a couple of wires to connect it up. Now, I don't own any remote control gear at all. I've never had a drone. I've never had a proper remote control car, so I don't own any of that stuff. So trying to keep my costs down, I've written a little protocol that allows two ESP8266 microcontrollers to talk to each other over something called ESP Now, which is a proprietary wireless communication method specific to those controllers. And that's made my own little remote control setup. In the picture you can see there's a ESP lashed up to a power bank and a Wii nunchuck, and there's another ESP connected to the rover, and by wiggling the joystick I can drive it around. Now, one of the things with the hoverboard motors is they do move quite quickly at full speed, like probably 15 miles an hour or something. So there's a speed cap. I've set one of the buttons up, so you push it and it kind of raises the cap slowly. So you start off really slow, you push a button, it speeds up a bit and so on, and you can drive it around. And while I was setting all this up, I've made sure there's a bit of a dead man's handle. So if it loses communication between the hand controller and the rover, or between the ESP on the rover and the motor controllers, it all shuts down. So anytime anything can't speak to the other end, it just shuts it right down, because 15 kilos of rover moving around quite fast is a mildly dangerous thing. But fiddling around with it, I've done a bit of mixing of how the power goes to the motors as you move the stick, and it's made it quite drivable, and the range is great. It's certainly enough for testing to begin with. And as I said, it's quite a big, heavy thing. So I really do want to try and stop it hitting people. Now, these ultrasonic rangefinders are another thing that loads of people will have had in an Arduino or a Pi starter kit and are just kicking around in a box. And I wanted to try and make it safer. I went a few weeks back to a maker and cosplay event in Southend, where there are loads of people there with Star Wars replica droids. It's a big hobby for people. They build replicas of the things from the movies, and they're full-size R2-D2s and so on, which are physically really quite big when you see one in the flesh, and move around reasonably quickly. They go through loads of testing to make sure they're safe, but they don't actually have any collision detection or collision avoidance, because that's not obviously visible on the movies. But I want to dabble with that, because when I come to use this in a game, there are going to be people around. I don't want it reversing into somebody. So I want to dabble with this. And my first attempt is to put some of these old school ultrasonic sensors at the front and the rear. Ultrasonic sensors are old, they're unfashionable, but they have a place. They still work quite well. And I had a bunch of them. I've arranged them in 2 arrays of 3 sensors, and they spread quite nicely at the front and the round. And if you get too close to anything, it kills the motor, although you can override it with a button on the controller. It doesn't work as well as I'd like. The range on the array seems to have been compromised by where I've mounted them. Perhaps they're only up to about a meter, which is kind of not far enough. So I'm going to have to do a bit more work on this and maybe add in a time of flight type LiDAR sensor, but that's for the future. But for now, it is kind of functional. So we're there. So that's a starting point. And then the next thing is I really want to map where it is. And a thing in my cellar of useful bits was an Xbox 360 Kinect. These were a hot item 10 years ago for people fiddling around making maker projects where you were trying to spot people and spot motion and map rooms and all that sort of. It was a big thing. And they're a webcam, but they also fire out a pattern of infrared dots onto the world in front of them. And they process this and they see how the dots are disrupted by objects in front of them. And they use this to do an estimation of distance. And you get what's called an RGB-D, so red, green, blue, and depth image. Now, things have moved on. There are far more capable RGB-D cameras around, but the Kinect still works. It generates quite a decent manageable point cloud for sort of doing mapping and finding things. And I had one. And if you want another, they're like a tenner. So going with my let's make this cheap, great. The big downside of the Kinect is it's physically big. They were designed to sit on top of a telly, probably maybe not a CRT telly, but certainly a chunky telly. And they're physically big and they've got a stand with a motor in and they move up and down and they don't really work nicely as a thing connected to a project. They're a bit of a mess. And there's a standard hack you can do. You can cut the cable and change it so that it doesn't have to use the huge power supply that comes with them and the weird sort of converter box to turn it into a USB port. So you can hack it off, cut some wires and do it. And I did all that and drove my Rover around in the field with the Kinect stuck on the front of it, and it rattled and rattled and eventually fell off. So I decided I'm going to have to fix this, and I found somebody online to put a recipe for cutting them down, removing some of the circuit boards, because Kinects do more than just be an RGB-D camera. They try and find people, estimate their pose, say where their arms are and that. And there's a computer inside them that does all that work, but I don't need that. I just need the depth camera. And I stripped it down, cut the frame back, made a slightly messy PSU to provide the different voltages to keep it alive. And it's a fiddly process to get done, but once it's done, it's like a quarter of the size and a tenth of the weight. And that now fits quite nicely on the front of the Rover. And once that was done, I popped it on and tried the open source software. And you can see on the laptop there, it color grades, as one of the tests or programs, color grades the image that you see based on how close it is. Red is close, blue is far, green is far. And it really, really does work nicely. However, during testing it, I killed my Kinect, which is sad, but they're only a tenner, so I bought another one. The thing that killed it is the power supply setup, as I said before, is really messy because I've got to take 40 volts in, I've got to turn out 1.8 volts, 3.3 volts, and 5 volts, and you can't take that from the USB because it takes too much current. And I managed to knock the screw and give it 7 volts on one of those lines and killed it. But yeah, so you can pick them up for a tenner. I'm thinking about designing a dedicated power supply, even though the Kinect is ancient now. I'm thinking about designing a dedicated power supply and USB daughter board that if anyone wants to cut one of these down and use it in a project, they can just get one of these boards because it'd be a very cheap thing to do. Might be saleable on Tindy. Who knows? I don't exactly have much business acumen, but somebody might want it. And the other thing you need to do is figure out where you are. Now, the camera's great for mapping a room, but it doesn't tell you where you are just sort of at this moment in time. And now, for that, you need a whole bunch of other sensors, and none of them are perfect on their own. The camera can't determine position and motion. You can use an accelerometer to say, okay, so I've accelerated at this rate, therefore I'm traveling at this speed, and you can add that up over time. But it's messy. You tend to get a lot of errors, but I had an accelerometer, an old MPU 6050. This is another thing that you're going to get in Arduino starter kits. I had one in a drawer, I put it up, I've connected it up. It's connected to the microcontrollers on the Rover. That's working. I had a compass as well. Compass is really quite good. Compasses are electronic compasses are pretty reliable, so it knows which way it's pointing. And I've also got a USB module. So for another location aware project, I bought a bunch of cheap USB modules, and given all these things, so you've got an accelerometer and you've got a compass and you've got a USB module and you can actually measure the rotations of the wheels as well, you should be able to figure out where the rover is. And ROS has a whole load of modules for combining that data, because this is actually quite a hard task. Combining that module, there are standard that data with a module, there's standard things for that should turn it into a fairly reliable measure of its position. But I said earlier, you'd be upset if there was no pi. Well, there is no pi. Mostly because I've never actually bought a Pi 4, and the Pi 3 I had set aside for this project seemed to struggle doing the stuff from the Kinect. Don't know if it was me when I was fiddling around with it. It certainly didn't seem to be very lively. And following a suggestion from Colin Hickey on somebody's Discord, I bought a Dell thin client PC, which gives you a very compact x86 PC with okay performance for very little money. A couple of upgrades from my PC parts box, and it's really nice for this. I've just mounted it on an old TV bracket because it's got a VESA mount. So all that ended up costing me about 40 quid in total. And if you've tried to buy a Pi 4 recently, you'll know that they're very hard to get hold of, apart from scalpers who are going to be overcharging like mad. So I've got all the various parts of Crufty connected up, but this is where part one of this all ends, because it's all up. I can read all the sensors. Everything functions, but ROS is a complicated beast. So part two will be me combining all those sensor readings in ROS and mapping how the rover moves around in its environment and does navigation. So this is just part one, but what I'm going to try and do now is do you a little navigation of the a little demonstration of the rover driving around in my front room. And this could be an interesting exercise in failure, because I don't know how this is going to work across a shared screen. Just give me a moment.
Nick, I don't think you've mentioned steering yet.
Give him a moment to set up.
Okay, the rover is alive. Just give me a moment. I'll just try and work out if I can share my screen and make all this work, because I have to do this via another application. So give me a moment. Let me start OBS. So what I'm hoping I can show you is a combination of a first-person view from the thing itself using a drone camera, and then also the Kinect. It will take a moment just to get this all going, because I've just turned it on. So any questions so far about this big pile of idiocy?
So a few people asking, how does this steer?
It uses skid steering like a tank, which is not ideal. Longer term, I think when I build the second version, I will use the Mars rover style steering. So that has 2 wheels in the middle that are fixed, and then 6 wheels, 2 wheels in the middle that are fixed, and then another 4 on the corners, and they rotate. Oh, I'm having it will refuse to connect. Classic.
It's the nature of live demonstrations.
Yeah, I know. Essentially, the remote desktop session doesn't want to start. Oh, here we go. You might have life. And then I have to. Sorry, this is a slow process, but I couldn't really leave it running in the background, which is slightly messy. Sorry for the slight delay. What I'm hoping now, I'll start virtual camera and then go to Zoom. And if people make can you see me now? I have a shared screen with me and a screen on. I don't know if I can make everybody see that. Is that possible? That's it. Thank you, whoever did that. So at the moment, you can see me chatting away. Hello, everybody. And also a desktop of the little PC sat on top of the rover, and also the view from a drone camera over here of what's going on at the moment. And with a bit of luck, I can start making everything move around, and you can see what sort of how the RGB-D camera works and things like that. I could show you the output from the sensors, but it's just a stream of very fast moving text at the moment. I could type without being full. Okay, so you should see a picture of one of those things that people drag to conferences, where they take a conference banner somewhere. I happen to have one of those kicking around. I just thought it'd make an interesting obstacle, and you see the sort of the rainbow view on the floor, because at the moment the sensor is configured to go quite small. But if I start driving the zone around, you should see it start. There you go. So it's found the object. It's highlighted it in green as being sort of fairly far away, but as I get closer, it will sort of bring it in, and it will slowly go red. Yeah, this is working reasonably okay. Yeah, tank steering is not super, but I've been driving it around outside a bit, and it actually is all right to drive. Hopefully people can see me driving around my living room. I threw loads of stuff out of my living room from this. So I have cleared up especially for you people. But as I drive around, you should be able to see how it's picking up the distances of things. And does that work for people? There we go. So you can see my armchair and footstool and things like that. So we've got a little bit of life there. As it gets close, too close, and it can't actually register it. Oh, too far around. Yeah, so I'm driving it off my shared screen. It's a bit laggy, so it's making it weird to drive. But there you go. So that's the sort of view the rover has of the world. And I think I've managed to do okay at getting this together. And thus far, I'm still under my budget, because I've spent about, I don't know, 150 quid, something like that, absolute maximum on this project so far. And as I said, an outdoor capable rover is an expensive thing. And I've been driving this around in the woods and car parks and so on, and it works really quite nicely. Lack of suspension's a problem, but as I say, version 2 is going to be probably involve, as I say, Mars rover style suspension, which is the weird thing with rockers and bogies and 6 wheels and turning at the corners and things. So try not to crash into things. There you go. So that's a little taster of how it sees the world. I'll close that now and stop sharing. So there you go, folks. There's a little quick talk through of what I've thrown at the spaghetti I've thrown at the wall to try and make this work. So what questions have people got, if any?
So there's a question in the chat. How do you control it by keyboard?
At the moment, I'm controlling it with the Wii Nunchuck thing that I talked about in the presentation. So it's a controller from a Wii, and I'm remote controlling it, and the range on it is got to be 100+ meters or something like that. So you can just drive it around. The little drone camera allows me to get a first-person view, so I can drive it around and see where I am. Somebody's mentioned the RDCam time of flight. That is actually something I'd quite like to buy. I'd quite like to get one of them because that's very affordable, and I'll probably be looking at one of them because that will actually work outdoors. Unlike the Kinect, the Kinect will work if it's very low light, but the sun kills the Kinect. But it was a tenner.
Hi Nick, Barry here. Did you find that the ultrasonic sensors interfered with each other when you had them in a bank of 3?
No, but I'm being moderate. I'm trying to be smart about it. So what I'm doing is I'm alternating how I ping them. So I'm pinging forwards, then backwards, then one corner, then the opposite corner, and like rotating around them. And that seems to work really nicely.
Ah, that's a good idea. Excellent. Well done.
And I do a bit. Sorry?
That's a really good project. This really impressive. I think it's very, very, very good.
And the way this all communicates is it all communicates with I2C. So the ESP that's driving the motors is talking I2C to the compass. It's talking I2C to the accelerometer, and it's talking I2C to a little Arduino that runs those ultrasonic sensors. And I wrote my own kind of code on there that does some heuristics. So it goes, right, I'll ping these in this order so that they don't interfere. But it then also kind of, okay, so which one's the nearest? Which is a believable reading? How much has it changed? That sort of thing. So, because you do get a few spurious readings with them. So I spent a little bit of time putting that together, and it works quite nicely. I say it's not perfect. There's a reason they aren't used in big serious projects nowadays, but they do still have a place.
Thanks.
Oh yeah, is it the same tech as the Xbox sensor? Yeah, it is an Xbox sensor. That is exactly what it is. That is a Kinect sensor, which I've cut down, removed a load of the blah. I've got one from a Xbox One Kinect as well, kicking around, which I might have a fiddle with in the future, because that is a better sensor. It works just generally better, but it generates a bigger point cloud, and it needs USB 3, which I would need a Pi 4 for, which I don't have. But the little Wise PC has got USB 3, so that should work. But at the moment, I just want to get started working with what I've built now, because what I've got is my base to learn the software and the base to learn doing stuff in ROS. But now I've got that, a lot of all the things that I've thrown on here, because they're old, they're well supported, they're well known. So it shouldn't be massively hard. It should actually be quite straightforward. And once I've got through that, I'll try and do a part 2 talk about Crufty the rover and how I've integrated the stuff together in ROS. Now, ROS is a little bit of a misnomer because it calls it robot operating system. It's not an operating system. It's a framework of allowing different things modules to talk to each other. It's a bit like having an MQTT server that everybody sends data to and everybody reads data from. That's sort of how it works. Any more questions?
I'm just back from a net outage. I'm really interested in how you're driving the motors or controllers, if you like. Do you happen to know whether the motors have got Hall sensors? And
yeah, the motors.
Sorry.
Yeah, the motors are Hall sensors, and I'm using the original controllers from the hoverboards, flash with open source software, and they do PID control of the power to the motors. So they try and match speed well. So I set a target speed, and they work towards that. And they work really nicely. I mean, basically a 30 quid hoverboard gets you 250 watt motors. And if you're lucky, a controller that's compatible with the open source firmware, because they're not all compatible, but quite a few are. And it works really nicely.
That's one controller per motor, yeah?
Again, it varies depending on which hoverboard you get, because some of them have like two controllers, one per motor, and some of them have one big controller with wires out to both motors. They vary a bit. They vary. There were a whole bunch of different versions of them. I'd say I've got both varieties.
It sounds like quite a lot of interesting challenges there. I'm wondering how they effectively sync the motors, or do they leave them unconnected so that you can tilt the two halves of the platform left and right and go in a circle? But then in that case, how do they arrange so that you go straight when both tilts are the same without the system drifting and you end up standing straight and riding in a circle?
All right. Yeah. So where they've got two separate controllers, one per motor, there is a link between them that has a protocol that talks between the two controllers that ensures they stay in sync and run at the same speed, and it's all synced up quite nicely.
And do you provide a standard electric bike kind of throttle signal into the PID?
No. The fork of the open software I'm using, what the hoverboard controllers come with is they come with a slightly rubbish Bluetooth remote control is one of the options they come with. So there's a port on the board, which is a UART serial port, and you send commands to the sort of primary controller of each pair and says, please set this wheel at this speed and set this wheel at this speed, and it will apply power until they meet that speed. And it will also send data back to you saying what the current speed is, because it measures the hall sensors. Now, I'm actually going to probably make my own fork of the software that actually also feeds back the ticks from the hall sensors, so you get the wheel rotation to give you an idea. The problem I would say with that is there's only, it's quite a large step on the hall sensors, so the ticks won't be very accurate. So on my to-do list is I bought some encoder, some wheel encoder PCBs, and I need to basically laser cut some little encoder wheels, stick them to the motors, and then read them instead, because I think even if I alter the software, the steps will be too big for it to be very accurate to feed back exactly how far it's moved.
Any chance you could do that a bit more easily by using an optical proximity sensor, very close range, on the tread of the tires?
I could do it. I mean, the optical proximity sensor is exactly what I bought. To do it. But they're designed to do, like when you see on motors, you see the patterns on them for the optical encoders. I need to make some of those patterns and then stick them to the wheels somehow and work out where I'm going to do that. But I can't remember the part number, but there's a common optical encoder used on expensive stepper motors. So like the sort of thing where you're paying hundreds of pounds per motor will use these particular encoders. I bought the encoders, you can buy them separately, and then I'll find out the pattern you need, engrave it on something. I might try and engrave it in anodized aluminium perhaps, because that will be quite tough, and then I'll fit it either on the outside of the wheel so that it can be read with an external sensor, or take the wheel to bits and see if I can fit it inside.
Sounds marvelous, thanks.
I've got a question. Could you possibly measure distance travel using LiDAR? Absolutely. LiDAR would be great. I'm trying to do this for tuppence. So at the moment, a LiDAR sensor would cost me as much as the whole project has cost so far. I can see LiDAR in my future, but at the moment, what I'm trying to do, I'm like a lot of people. I get a big project and think, yeah, I'll do this thing. This will be awesome. And then I don't always follow through with it. So yeah, also, yeah, dirt on the encoder would be bad. So what I'm trying to do here is spend about 150 quid, couple of hundred quid, have this thing that I can prove to myself, is this a practical project, before I throw hundreds and hundreds of pounds at it, because the final thing could be quite expensive. But yeah, LiDAR is almost certainly in my future. The Kinect is okay indoors, outdoors it's useless, and it hasn't got the range of LiDAR. LiDAR would be lovely.
Hi, Nick. I guess your batteries are LiPo. How do you protect for under voltage?
That is where hoverboards suck. They do actually do under voltage protection. So the controllers, if the voltage goes below, I think 32, they shut off, and they shut off all the power to the motors. It's a 10S pack, so that's about 3.2 per thing. So that cuts it off quite early. The thing that causes the hoverboards to kill their batteries is, as I think I mentioned in the talk, although I was rambling along a long way, is the controllers never completely switch off. So they shut off the power to the motors, but they kind of run the microcontroller pretty much all the time. So they're using a few milliamps all the time, and that will eventually flatten the battery. But on a project like this, where I'm actively working on it, that's not going to become an issue. And I've put a battery isolator switch in as well, so that when I finish working on it, I just flick the battery isolator switch, which is also acts as a safety cutoff. So if its wheels are spinning and I can't stop it, I just flick the switch and it will kill all the power. The LiDAR that's 80 quid, somebody said RP LiDAR, that is a good value LiDAR, but it doesn't work outdoors. The one, there's a later model which does work outside, and that's the one that's about 150 quid. Anybody else? Oh, Radar Person says, is that the microwave sensor? Yes, that would also be cool. If Anthony said Andreas Spice has an episode about an improved Radar Person sensor, that is probably a microwave sensor, and actually I should look at that, because that would be a very good way of spotting somebody. I seem to remember them saying before, so certainly earlier version, that they're so sensitive that they find people behind doors and stuff. So, but yeah, that is important. And what I'm looking at here is good value ways to make this safe. So if it spots somebody, it just stops.
He did a video about a microwave detector that basically would detect him across his living room at such a distance that it was difficult not to set it off, if you like.
Yes.
The latest is about a sort of linear PCB radar detector, which I think is a bit more focused.
Somebody there saying their inspiration for school project. What I'm currently trying to do, there's only a relatively little up there at the moment. My intention is, I will share the link, is I am putting all of this on GitHub. So absolutely all of it will be on GitHub. Hang on, I'll share the link. Your repositories. It's a bit of a skeleton at the moment, but I'm going to put all my code in there, all my 3D designs, basic wiring diagram, all that sort of stuff. I'm going to deliberately put it on GitHub, so that if somebody thinks, oh yeah, I want to build a thing, same as with my remote control code for the ESP Now remote control, because sometimes people want to make remote control projects that just have like 2 cheap, I don't know, 3 quid microcontrollers instead of spending 100 quid on a proper radio control thing. It's not as reliable, but it's good enough for a little bit of messing around. Yeah, the £150 LiDAR, I can't remember what it's called. I'll try and share it on the group. But I did a bunch of reading into this because I was thinking of buying one. It was like, man, I can't get the super cheap one. I have to get the more expensive one. There are about 4 models of the RP LiDAR, and it's yeah, 2 of them work indoors and the rest work outdoors. Any more?
Excellent. Thank you very much.
Thank you very much. I hope that kept people entertained and they saw some of the weirdness of my house.
Excellent. Thank you ever so much.